Hi, my name is Manish Gupta, and in this video, I'm going to talk about Meta Llama 3. Okay, so let's get started. So Meta just recently released Llama 3 checkpoints. So let's start by first understanding why it matters, right? So how does Meta Llama 3 perform? Meta actually released two different checkpoints, one of size 8 billion and the other of size 70 billion. And they actually released both pre-trained as well as instruct checkpoints. So instruction tuned checkpoints. Okay. So if I look at the pre-trained version, right, first let's look at pre-trained version. Okay. And there are these five tasks or other five different data sets, benchmark data sets that it has been evaluated on. MMLU, AGI eval for English, big bench hard, arc challenge and drop, right? So, and then you compare, let's say the 8 billion checkpoint with the Mistral 7 billion or Gamma checkpoint, right? What you observe is that Meta Llama 3 is 66.6, which is way better than any of these numbers. Well, they're published numbers and as measured by them, right? So that's that. In the Meta's blog, the paper is still awaited. The paper is still not out, but if you look at other benchmark data sets also, 45.9 versus Mistral gives you 44 and Gemma gives you 44.9 and so on, right? So all across, in most data sets, you would observe that the pre-trained checkpoint, 8 billion checkpoint is better than these 7 billion state-of-the-art models in that senses. Okay. Now, if you also compare the 70 billion checkpoint, again, a pre-trained version, it is extremely better, right? I mean, in some cases, it is like 20 points kind of improvement and so on, right? Almost 20 points improvement across different data sets. Okay. Now, again, they also compare this. So since it's 70 billion, they also compare with like larger Mistral models and Gemini Pro model, which is also pretty large in that senses. And they basically show that their Meta Llama 3 70 billion is establishing a new state of the art in that sense. Okay. Now they are also pre-training a 400 billion plus model. So, and the interesting part is that this model and its training is not yet done. At least the blog article basically says that it is being trained as of now. And as you see across all of those benchmark data sets, this model is actually just doing really well, and it's not yet done. So it basically may improve even further. Okay. Compared to that, they also instruction tuned instruction tuned these pre-trained models. So instruction tuned models, of course, are better than Gemma instruction tuned or Mistral instruction tuned models, but they are also better compared to the pre-trained model. Of course, I mean, that is why people do instruction tuning. Although they have done instruction tuning for, for ensuring that there is also safety in the outputs and so on. Okay. Now, Meta Llama 370 billion is again better than Meta Llama 370 billion pre-trained checkpoint. So that's that. However, okay, so these numbers are not directly comparable. So not all of them. So here the data sets that they've reported on are these five, while here the data sets are slightly different. So you see just the MMLU actually matches here. Everything else is in fact different. So it's not like everything is comparable, but on MMLU, you can actually compare across these different checkpoints and observe that these instruct-tune checkpoints are better. In fact, they're also training an instruct-tune 400 billion plus model. And as you see, that's like the best. So these numbers are like the best possible. So on MMLU, it gets 86.9, 86.1 compared to, Gemma 7 billion instruction tune, which gets like only 53. Or, Mistral 7 billion, which basically gets like only 63.9 and so on. Okay. So essentially saying, yeah, I mean, I think Meta Llama 3 is like a big leap in terms of performance across several benchmarks. Okay. So how does Llama 3 compare with Llama 2? Well, from a pre-training perspective and so on. So Llama, as I said, Meta released Llama 3 checkpoint for 8 billion and 70 billion pre-trained as well as instruction fine-tuned ones with a knowledge cutoff of March and December 2023 for 8 billion and 70 billion checkpoints. Okay, so it basically understands everything. It's sort of a fresh model now in that senses. So that's why it's better compared to Llama 2 anyway. Okay. And then, as we observed on the previous slide, it's a major leap in accuracy over Llama 2. And the previous slide I compared with Mistral and Gemini and Sonnet from Claude 3, Claude and so on, right? So basically, I compared with several of those, and they have been shown to be better than Llama, right? So therefore, therefore Llama 3 is of course better than Llama 2. Okay. So it's a major leap in accuracy for various kinds of benchmarks for reasoning, code generation, instruction following, and so on. It also has reduced false refusal rate. So essentially, refusal rate basically means that when a model sort of feels that, hey, you're trying to jailbreak or do something nasty with it, it basically refuses to come up with a reply. It has reduced false refusal rate. It also has improved alignment and diversity in model responses. So the instruction fine-tuned model is really nice. It sort of can follow the instructions, much better. So it's better aligned and also has diversity in the responses. Architecture is just a decoder-only transformer with the with a tokenizer with a vocabulary size of 128K. It uses group query attention for faster inferencing and faster training as well. So, and it has like about 8,000 tokens. Okay, that's the context length. It has a token efficiency of up to 15% fewer tokens compared to Llama 2. Okay. So therefore, even though the number of weights are slightly 1 billion larger than Llama 2, it still is as efficient at inference time as Llama 2 itself. Okay. Now they also did some human evaluation using 1,800 prompts across 12 different use cases. These use cases are named here, asking for advice, brainstorming, classification, closed question answering, open question answering, coding, creative writing, extraction, inhabiting character persona, reasoning, rewriting, summarization, and so on. Okay. And what they asked the humans to do is to basically, look at, let's say, Claude Sonnet's results and Llama 3's results, Llama 3 70 billion instructs results, and then choose whichever wins, whichever is better. Okay. And as you see, they compared with 4 different models: Claude Sonnet, Mistral Medium, GPT 3.5, and Meta Llama 2. Okay. So they compared Llama 3 70 billion instruct with all of these, 70 billion instruct with each of these. And what they've observed is that, of course, in most cases, the win rate is higher than 50%, basically saying people prefer Llama 3 more compared to these models on a whole bunch of key use cases. Okay. So more details about how is Llama 3 trained? Well, it's pre-trained on 15 trillion plus tokens. That's probably the only model which has been pre-trained using such a large data set, okay, or such a large compute, okay. Training data set is 7 times of Llama 2 and has 4 times more code than Llama 2, okay. Over 5% of Llama 3 pre-training dataset contains non-English data over about 30 languages. So basically, however, they also caution that we do not expect the multilingual capabilities to be as good as the English capabilities. Okay. They did a whole bunch of data filtering to ensure that the pre-trained data is clean and nice, using several kinds of filters, heuristic filters, not safe for work filters, semantic deduplication approaches, and also text classifiers to predict the data quality. Now, these text classifiers to predict the data quality have been trained using Llama 2 itself. Okay, so they use Llama 2 to generate trained data for the text quality classifiers and then train based on that data. They have several pre-training data sources, just like every other model, and they have tuned the mixing proportion by doing several experiments. So Meta has also released other kinds of trust and safety tools. So they already had released Llama Guard and CyberSec Eval. So they released, Llama Guard 2 and CyberSec Eval 2 versions of the same. And they also put out another thing called as Code Shield, which is an inference time guardrail for filtering out any insecure code which is produced by the LLM, so that you can actually be more secure and safe about the outputs generated by the LLM. Okay. While training, they basically tried or used 3 different types of parallelism: data parallelism, model parallelism, and pipeline parallelism, and they trained on like a crazy large compute cluster, 24K GPU cluster. Okay. Llama 3's training efficiency, they basically took all kinds of steps to basically make training as efficient as possible, hardware kind of efficiencies, and then, compiler level and so on. So several kinds of efficiencies, in fact, right? And therefore the training efficiency is actually 3x of Llama 2. Okay. For instruction fine tuning, they basically followed like these all kinds of things that you can potentially do. So supervised fine tuning, plus they also did rejection sampling and then PPO and then DPO. So people typically don't do RLHF and DPO together, but it seems like they've done multiple phases. Supervised fine tuning, which is usual, and then they also did rejection sampling and PPO, but then they also did DPO on top. Okay. The quality of the prompts basically for SFT for this phase, as well as preference rankings for PPO and DPO, are actually super important, is what they mention in this blog. But again, the paper is yet to come, so you'll know how important these are. Hopefully they'll show ablation results in the paper. Okay. Llama 3 has been developed on TorchTune, which is basically the new PyTorch native library for deep learning, basically, or rather for LLM, sorry, right? So TorchTune, which is a new library, PyTorch library for large language models for easy authoring, fine-tuning, and experimenting with large language models. So TorchTune is, of course, also integrated with Hugging Face, weights and biases, Luther AI, and so on, which basically makes Llama 3 and all the nice recipe scripts that they have made available directly, compatible with these other libraries. Okay. So in summary, Llama 3 basically they've released 8 billion and 70 billion pre-trained and fine-tuned checkpoints. It's significantly better in quality compared to Llama 2 and other models like Mistral and Gemini and Gemma and so on. It has 8K context length, trained with 15 trillion plus tokens on a custom-built 24K GPU cluster, and shows great performance on several benchmarks, reasoning, math, coding, and so on. Okay. With the Llama 3 8 billion checkpoint being even better than Llama 2 70 billion checkpoint sometimes. Okay. So of course, in the future, they would want to do everything that people do with large language models these days. So support multilinguality, support multimodality, have longer context length, and sort of continue to overall improve the performance. Okay. So that's it about Llama 3. Hope you liked the video. Thank you for watching. Connect with me on my LinkedIn. I'll look at my research on my homepage. Thank you.